I welcome you, my dear students, for the first segment of our grade 10 science lesson of St. Peter's College, Colombo 4, Nigambu branch. Today the lesson we are going to discuss is quantification of elements and compounds. In this lesson we are going to discuss about the way finding the mass of elements and compounds. In our day-to-day life, we use different measuring units to find weight. In day-to-day life, we use different measuring units to find the weight. First one milligrams, second one grams, third one kilograms. In your day-to-day life, you have experience of these measuring units we use. And here the smallest unit we use to measure the mass is attogram. The smallest unit we use to measure the mass is attogram. 1 attogram is equal to 10 to the power minus 18 grams. 1 attogram equals to 10 to the power minus 18 grams. Now, in the periodic table, you know, the first element is hydrogen. Hydrogen is the lightest element. Hydrogen is the lightest element and the mass of hydrogen atom is given here. It is 1.674 into the power 10 minus 24 grams. Masses of some other atoms also given here. Mass of carbon, mass of sodium, mass of chlorine, mass of potassium given here. Here mass of carbon atom given 1.993 into 10 to the power minus 23 grams. Mass of sodium atom 3.819 into 10 to the power minus 23 grams. Mass of chlorine atom 5.903 into 10 to the power minus 23 grams. Mass of potassium atom 6.476 into 10 to the power minus 23 grams. From this you can get idea how they are small, very small. We cannot see from our naked eyes, even we cannot see how that is small, that much they are very small. So we are going to find out the mass of this. We are going to find out mass of this. We'll see how we can find out the mass of these very small atoms and compounds. First of all, we have discussed about this. The word you know that isotope. We have learned this in your second lesson. Isotope. What is known as isotope? Isotope means the same, when you get the same atom with different masses. When you get the same atom with different masses, we call as isotope. The definition of the isotope given here. Same atom with different mass number but with the same atomic number. There is no any difference of the atomic number but the mass number will be different. When you get this carbon, you know top of this carbon atom we show here the mass number. This is the atomic number. Atomic number won't change. Atomic number do not change but the mass number can be changed. So different mass numbers we call as isotope. Here when we get the measurement or the quantification, when we get the mass, we use this carbon 612 isotope. That is the standard atom we use. Carbon 612 isotope. Here you can see here carbon 612 isotope is used to express the masses of other atoms. Now we are going to compare the masses of the other atom with this carbon. The first of all earlier for this instead of this hydrogen has used, but today the standard method is carbon using for this. Carbon, but the carbon, not just carbon, carbon 612 isotope using for this. Carbon 612 isotope is used to express the masses of the other atoms. We'll see how we'll compare the masses of the other atoms. Right, the first unit we are going to discuss is AMU, the short form AMU. AMU means atomic mass unit. Atomic mass unit. We'll see how to get atomic mass units. Atomic mass unit. You can see here the equation of AMU 112 into mass of carbon 612 atom. Again see AMU or atomic mass unit equal to 112 into mass of carbon 612 atom. Right? Here another way of writing this. Atomic mass unit equal to mass of carbon 612 isotope divided by 12. The same thing. The same unit we have written here. In the earlier slide I show you the mass of carbon 612 as carbon mass I gave you. Right? That carbon mass here and it is divided by 12. This is very important part when we find out the other atoms, relative atomic mass. The other topic we are going to discuss is relative atomic mass. This is needed. Atomic mass unit is needed. Right? Now when we divide this is the answer we get. 1.67 into 10 to the power minus 24 grams. This is the answer. Again see, answer is 1.67 into 10 to the power minus 24 grams. When we go to the other calculations also, if you know this, it is easy to do the calculations. Otherwise, you have to divide this and get. Yeah, don't think you should by heart this atomic mass, the mass of carbon atom. No. If need there for the calculation, for the questions in the paper, the facts they will be given. No need to worry about that. But if given like this, you have to divide and get the answer. But by heart, if you know this, it is easy to go to the other calculation. So the atomic mass unit is 1.67 into 10 to the power minus 24 grams. Otherwise the method is this, mass of carbon 612 isotope you have to find out, and find out mean in the questions it will be given and you have to be divided by 12, then the answer will be this. It is easy if you study this by heart. Not much difficult. Answer 1.67 into 10 to the power minus 24 grams. Right? We'll go to the next now. Right. This is a very important part after atomic mass unit. This is needed. RAM, relative atomic mass. RAM, relative atomic mass. Relative atomic mass means the mass of atoms. I told you that atom is very small, molecule is very small. As we are measuring from grams, milligrams, kilograms, we cannot measure them. They are very small. Because of that, the way we are finding the mass of this, we are comparing with the other atom. For the comparing part, we take carbon atom. For the comparing, we take carbon atom. From this relative atomic mass, so we are comparing the mass of the other atom with carbon. Right here, the definition given here, this is the equation. We'll see the definition first. You have to by heart, right? There's no any other method. You should know these, right? We'll see the definition. How many times an atom of a given element weighs as much as 1/12 the mass of carbon-12 isotope is the relative atomic mass of that element. Again, see how many times an atom of a given element, how many times an atom of a given element weighs as much as 1/12 the mass of carbon-12 isotope is the relative atomic mass. Easily you can find out this here from the equation. Relative atomic mass, this is the symbol for the relative atomic mass. We use capital A and simple R. AR mean relative atomic mass symbol. Equation, mass of an atom of the element. Right? You have to write here mass of the atom as example. If you think sodium, if you want to find out relative atomic mass of sodium, you have to write here mass of the sodium atom. You have to write here mass of the sodium atom, and after that it is divided by atomic mass unit. It is divided by atomic mass unit. Instead of this part, we can write atomic mass unit. This is the equation we use for the atomic mass unit. 112 into mass of carbon 612 atom. Remember, we discussed of that atomic mass unit. Right, atomic mass unit we are writing here. So, if there is any attempt to find out the relative atomic mass, we have to write relative atomic mass equal mass of the atom divided by atomic mass unit. Do you remember the answer we got for the atomic mass unit earlier? Right? This is the atomic mass unit. 1.67 into 10 to the power minus 24 grams. It is easy if you know this. 1.67 into 10 to the power minus 24 grams. Now here, instead of this, you can apply it here. 1.67 into 10 to the power minus 24 grams. If given the mass of the atom, you have write those two and divide and get the relative atomic mass. Right? We'll go to the next. Now here, in your textbook you can see relative atomic mass of the atoms given here. Again I want to tell you this, Pute, no need to worry about relative atomic mass, you no need to by heart them. In the questions they will be given you. Here these are for first 20 elements. First 20 elements, atomic number you should know. There's no any excuse for that. Atomic number you should know. In order first 20 elements you should know. Right? But the relative atomic masses no need to by heart. In the questions they will be given. These three you should know. Atomic numbers 120 elements in order 1 first 20 and the symbols of them you should know. But the relative atomic masses will be given in the questions. This is in your textbook also you can see, right? Now see the way of doing the calculations, right? There's a question like this. The true mass of carbon 612 atom is 1.99 into 10 to the power minus 23 grams. Therefore, the relative atomic mass of oxygen can be found as follows. Now here in this question going to find out relative atomic mass of oxygen. Relative atomic mass of oxygen. Right? Here mass of oxygen atom you have right. Here mass of oxygen atom, and here 112 into mass of carbon 612 atom. This is atomic mass unit. This is atomic mass unit. Mass of oxygen atom divided by atomic mass unit. Here, and when we simplify, the answer we get is 16.03. 16.03. When we round off it, we take it as 16. When we get relative atomic masses, there is no unit for that, right? There is no unit because we comparing that. According to foregoing calculations, you may understand that the relative atomic mass has no units. For relative atomic mass, there is no unit. This is very easy. If given the facts needed, you have to divide and get the answer. Then you can find out relative atomic mass. In some questions given, you will find out like this, relative atomic mass. In some questions, relative atomic mass given you and asking some more things. Right? Again another question like that. Find out the relative atomic mass of potassium. Find out relative atomic mass of potassium. So you have to write mass of potassium atom divided by atomic mass unit. Then divide and you have to get the answer like this, 39. Calculation part you all have to do. You all have to practice them. No help for that. You have to divide and get the answer. If you know here atomic mass unit, I told you that several times, it is easy, right? It is easy, then easily you can divide and get the answer. Right? Up to here, okay? Now we'll go to the next one. Relative molecular mass. Relative atomic mass is over. Now we are going to find out what is relative molecular mass. The symbol is MR. Same way, not difficult. We'll see how to find out that. As the earlier definition, how many times a given molecule? Now you know what is a molecule. You know difference between atom and molecule, right? Two or more atoms combine and form a molecule. Now we are going to find out the molecule, relative molecular mass. How many times a given molecule of an atom of molecule of an element or compound. Now there is a problem here with it. Element or a compound. How many times a given molecule of an element or a compound? Are there molecules in elements? Are there molecules in elements? Yes. If you remember. If you get homoatomic molecules, do you remember them? O2, N2, H2, they are homoatomic. They are homoatomic molecules. That's why it's called as element. Compound, you know, the basic unit of compound is molecule, right? How many times a given molecule of an element or a compound weighs as much as 1/12 the mass of carbon 12 isotope is the relative molecular mass of that element or compound. Again, see the definition. How many times a given molecule of an element or compound weighs as much as 1/12 the mass of carbon 12 isotope is the relative molecular mass of that element or compound. This is the equation. As we wrote earlier, relative molecular mass equal mass of molecule of an element or compound. That's the way we are writing the definition. Element or compound, right? Mass of a molecule of an element or compound divided by atomic mass unit. Divided by atomic mass unit. And we have to divide and get the, simplify and get the answer for that. Here there is an example for that. Carbon dioxide. Finding the relative atomic mass of carbon dioxide. Mass of a molecule of carbon dioxide divided by 1/12 into mass of carbon 612 atom. Right here it will be given 7.31 into 10 to the power minus 23 grams divided by 112 into 1.99 into 10 to the power minus 23 grams. Simplifying and we can get the answer as 44. Right? Again, there is no unit for relative molecular mass. There is no unit for relative molecular mass. And here there is another example. Find out the relative molecular mass of water H2O. Mass of H2O molecule divided by atomic mass unit. Answer will be 18. Answer will be 18. Right? This is one method of find out the relative molecular mass. This is one method of finding relative molecular mass. There is another method of finding relative molecular mass. We'll see what is it. Right? Finding the relative molecular mass of carbon dioxide. Now we are going to find out relative molecular mass of carbon dioxide. How to find relative molecular mass of carbon dioxide? When it comes to carbon dioxide, here you can see in carbon dioxide molecule there is one carbon atom and two oxygen atoms. One carbon atom and two oxygen atoms. If you remember now, I show you a table with relative atomic masses of first 20 elements. In that table, it has given. I told you that if for the calculation, if need relative atomic masses, in the questions they will be given. No need to be worried about that, right? Now we are going to find out the relative molecular mass of carbon dioxide. You should know the difference now these two, right? If that is only one element, we call it as relative atomic mass. If it is a molecule, we call it as relative molecular mass. Right now here from that table we can get carbon relative atomic mass is 12. Oxygen relative atomic mass is 16. Carbon 12, oxygen 16. These both are relative atomic masses. How many carbon atoms are there for carbon dioxide molecule? Only one carbon atom. How many oxygen atoms are there for carbon dioxide molecule? There are 2. Now the way we find it is very easy. Right, there is one carbon here. This is carbon relative atomic mass, and here oxygen 16. There are 2 atoms oxygen, 16 into 2. 16 into 2 mean 32. 32 plus 12, answer will be 44. This is the way we find in the relative molecular mass of compounds. Relative molecular mass of compounds. When we know the relative atomic mass of the atoms given, we have to add them and get the answer. Right, there are some more examples. Before go to this example, you can see there is another name given here, relative formula mass. Now how many things we learn? Relative atomic mass mean atoms mass, and relative molecular mass mean molecules mass. We got now here another name, formula mass. Relative formula mass. Relative formula mass when making ionic compounds. When making ionic compounds, the very easy example is sodium chloride. Sodium chloride form as lattices. There is another lesson to discuss about those lattices, but just keep in your mind, these are ionic compounds. For the ionic compounds, we use that word as relative formula mass. Right? Relative formula mass, but don't worry, same procedure we are using for this also to find out relative formula mass, only the word is different. The word we are using formula mass for the ionic compound. Right? ionic compounds, magnesium oxide, calcium carbonate, potassium sulfate, they are sulfate, they are ionic compounds. But the same method we use to find the relative formula mass of them. Now we can see here magnesium oxide here. Magnesium relative atomic mass is 24, oxygen 16. So how to find out relative formula mass of this? 16 plus 24 was the answer 40. Right? Relative formula mass of magnesium oxide 40. Right? Then we will see calcium carbonate. How to find out relative formula mass of calcium oxide? Calcium here 40 plus carbon only one atom 12 and here oxygen 3 16 times 3, right? Multiply all these and we have to add and get the answer. When it comes to potassium sulfate, potassium there are 2 atoms. Potassium there are 2 atoms. Then 39 into 2. 39 into 2 plus sulfur 32 plus oxygen 4. There are 4 atoms. 16 into 4. This is all we have to add. Then we can find out relative formula mass of these compounds. Right. This is the activity you all have to do. You have to find out relative molecular mass of the following substances, right? I told you at the end of the questions, relative atomic masses are given, which are necessary. Carbon, hydrogen, nitrogen, oxygen, sulfur, chlorine, all are given here. Then you have to add them and find out relative molecular mass. These are okay, I think no problem. When you come to the sixth question, see the Roman number 6, right? In Roman number 6, this is the way it's doing. Carbon 12 plus, this is urea, oxygen 16 plus, now nitrogen. You can see nitrogen, there are 2 atoms, right? Not only 1. NH2, there's a bracket and 2 here. Okay, then nitrogen 2, not only 1. Then 14 times 2. 14 times 2 plus, and hydrogen, you can see 4. 2 into 2. Hydrogen 2 into 2, that means 4 into 1. Then you have to multiply and add them. The others are not much difficult. You have to do this in your worksheet study pack. I have sent them these questions like this. You all have to do. If you haven't completed that, after now I have explained you can do them. And from next lesson, the other part will be discussing. Next time we'll be discussing the other part.